Hi all, I had a couple of questions on the last problem in the study guide, and I just wanted to go over it with you real quickly again, just to make sure that you get vectors just a little bit better. We did kind of somewhat rush through those a little bit. So here we go. Let me move that out of the way real quick. Let me just say, for example, we have something like this. We have vector S, okay, is, something really simple, something like 4i plus 2j, something like that. Okay, and then we have vector t, let's say here, that is negative 2i, plus, just real straightforward, let's make this 3j. Now what this means here on the unit axes, or the x-axis right over here, and the y-axis, the coordinate plane, we've got 4i, 1, 2, 3, 4. I is the unit vector on the x-axis, so 4i just means over 4 units on the x-axis, and 2j means up 2. So 1, 2, just right there. And so s is going to be this vector right here. And we can figure out the bearing and the magnitude of vector s. It's really straightforward. It's just going to be the length of vector s. I mean, we could look and guess it's about 4 units there, a little bit under that, right? Just using Pythagorean theorem, even here, this is 2 units, right? This is 4 units, and 2 squared plus 4 squared, what would that be? 16, 4, 20, radical 20. I don't know. And we can see that'd be, yeah, a little over 4 units, 4.5 units, 4.5 units long. And so that's the length of this vector right here, 4.5 units. Whatever units we're talking about, centimeters, whatever. And this is vector s. And the bearing of s, by the way, this would be angle theta right here. And so the tangent of theta, remember, is SOHCAHTOA. It's opposite over adjacent. So it's going to be 2 over 4. So the tangent of theta, opposite over adjacent, would be, the tangent of theta would be 1/2, or theta would equal the tangent inverse of 1/2. Let's see what that is. I mean, that seems like to me tangent inverse of 1 divided by 2 in degree mode. And yeah, it's about 26.56. So let's go with 27 degrees. Let's round it up to about 27 degrees. So theta is approximately 27 degrees, and it's in the first quadrant. That makes sense. It's not. We don't have to do anything past that. So. Vector s, its rectangular coordinates are 4, 2. We could write it like this, 2, 4, 2. It's not an ordered pair, it's a vector, so it's got a bearing and a magnitude. We could write it like that, the rectangular coordinates, or we could write the polar coordinates. We could write the polar coordinates like this, 4.5, and we could write it 27 degrees. That would be the polar coordinates of that vector. All right, now vector t, same thing. Let's do vector t in a different color, like green, something like that. Okay, so t, let's see, we're going to go negative 2i. So let's see, over 2 on the x-axis and up 3. 1, 2, what would we come over about right here? 3. Okay, this is going to be vector t right here. There we go. Vector t. And we'll put a little vector t right here. And we could figure out also the magnitude and the bearing of vector t. I mean, it's just, again, real straightforward. This is 3. This is the length 3 right here. Let's do it right over here. Let's see. Sorry about that. So we'll make this a length of 3 right here. We'll put a length of 2 right over there, right? Okay, so we can see that just using Pythagorean theorem here, it's just going to be the magnitude. Vector t is going to equal radical 3 squared plus 2 squared. I didn't write s out like this, but it's the same thing. It's just Pythagorean theorem. So what is that? 9 plus 4. That's going to be 13, radical 13. So it's going to be 13 raised to the 0.5, that would be 3.6. Okay, so vector t is about 3.6 units long. And what is the bearing of that? You know, just a guess. It says like 120-degree angle, something like that. Just guessing. My bearing off the positive x-axis, doesn't that look like it's about 120 degrees? I don't know. Let's see. Well, the tangent of the reference angle, that's going to be this angle right here, that's the reference angle, is going to equal the opposite, 3 over 2. And so theta r, I don't know, let's see the tangent inverse. Wait, -2, this is -2. I was thinking, wait a minute, what quadrant am I in? Tangent inverse of 3 divided by -2 is going to be, yeah, about -56 degrees. And so the reference angle is -56 degrees, which means the bearing of the t vector there, we're not going to give it the reference angle. We want the actual bearing off the positive x-axis. So we're going to add 180 to that, -56. -56 plus 180, and I'm at 124. Yeah. So the bearing right over here, this is going to be 124 degrees. And hopefully that makes sense to you. So for vector t, the rectangular coordinates are -2, 3, just real straightforward. And the polar coordinates are going to be, I use the bearing off the positive x-axis. It's just going to be 180 plus -56. It's going to be 124 degrees for the polar coordinate. The bearing's 124 degrees, and the size, what is it, 3.6 unit cells. Okay, I got stuck using yellow. I don't see it very well. Okay. Hopefully all that makes sense. Now, I hope I can do this. Let me see if I can. I want to take, if I can, I want to take, I think, look at that, check it out, I can do that. Oh, that's so much fun. Look at that. I'm going to take the t vector right there. Look at that. Hot dog. That was just fun. And I'm going to put it right there, and I'm going to add the two vectors together because I have to go to the end of the S. If I'm a little ant walking along, walk, 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 and then I have to come up over here, and then this is my new vector right here. This is the S plus T vector right here in purple. This is the S plus the T vector, and I want to find the magnitude of that vector and the bearing. Just a guess. It looks like it's about, I don't know, 5 units long, something like that. So okay, we want, well, first of all, we just want to add the two. We just want to take the sum of the two vectors. So C plus T, it's super straightforward. It's going to be 4i plus -2i. It's going to just be 2i. 4 plus -2i. Okay, that's going to be the x component of the sum of the two vectors, and the y component is going to be 2i plus 3j, or 2j plus 3j. It's going to be 5j. So this is the new vector, 2, 5. And if you come over here, look, it makes sense. 2, looks like it's over 2, and it's up 5. Over 2, up 5. There's the triangle right there. Over 2, up 5. Yeah. Okay. So now the magnitude of this new vector here is going to be 2 squared plus 5 squared. That's just in that right triangle right here, right? 2 squared plus 5 squared. So what would that be? 25 plus 4, 29, radical 29. 29 raised to the 0.5. 5.4 approximately. Yeah, so it's going to be approximately 5.4 units long. That's the magnitude of the sum of the two vectors. And the angle right over here, let's pick pink or something, right? Okay, there's the magnitude of this new triangle right over here. Okay. The magnitude, the tangent of theta is the opposite. The opposite, remember, this is 5. This is 5, right? 5. It's 5 over the adjacent, which is 2. And so theta is going to equal the tangent inverse of 5/2. And we're in the first quadrant, so my reference angle is going to be my actual angle in this quadrant. And so I'm just going to take the tangent inverse of 5 divided by 2. 2, and make sure you're in degree mode if it's degrees that we want, not radians. So 68, got 68 degrees. Doesn't that look like about a 68 degree? Looks like that to me. That's about 68 degrees. So the sum of the two vectors is going to be, I don't know, the rectangular coordinate. So the sum of the two vectors is going to be 2, 5. Okay, and the polar coordinates is going to be the length, the magnitude of the vector, and the degree, the bearing off the positive x-axis. Hopefully that makes sense. Okay, I'll see you all later, and ask me any more questions. I don't mind at all making the videos, okay? And please don't hesitate to ask me if you want to work in the classroom one-on-one too. I can help you do that. All right, take care.